Hi, my name is Vivek. I am a software engineer. I make videos about Kubernetes, containers, Go as a programming language, and software engineering in general. In this particular video, we are going to look into how we can create a Helm chart for your application that you have already developed. So in some of the previous videos, we just went ahead and created an application. Then we created manifests, Kubernetes resource manifests, so that we can deploy that application on top of Kubernetes. In this particular video, we are going to look into how we can actually Helmify, or how we can create Helm chart for the application that we have already created. So if you are not very familiar about these terms, for example, Helm chart, repo, and release, I have also made a video about uh, basic understanding or basic building blocks of Helm. So maybe you would like to check that out. So uh, this is the project structure that we have as of now, and this is the project that we have created. And here is this is pushed in my GitHub repo already, if you want to check that out, right? So this is the project structure. We have manifests, and this application consists of two components. One is REST API, and this another one is the MySQL database that we are going to run, right? So this is the application, this is the project that we are going to create a Helm chart out of, right? So as we discussed in the last video, in the Helm chart, we basically try to specify all the manifests that should be deployed as part of the application deployment, right? So now what we have to do is we have to somehow use all these manifests that we have here and package them into a Helm chart, right? But before that, we should first let's just go ahead and try to create a dummy Helm chart, right? And then in that Helm chart, we are actually going to copy all these manifest files. Again, in one of the previous videos, I actually created a dummy Helm chart repo and Helm chart application, and then I actually explained everything or every directory in that Helm chart application. So you should check that out. Let me just quickly open this on Visual Studio Code. And now, as we can see, we have our Docker file here, we have code, and we have all the manifest in the manifest directory. And this is the application that we are going to convert into a Helm chart, right? So let me just go ahead and try to create a what should I say, Helm chart, very basic Helm chart that is going to have uh, some test applications, some test deployments inside it, and I'm going to name it Helm because this is what people usually do. For example, let's say your application is library and you want to create Helm chart for your application. In the same repo you are going to have a directory named Helm, and everything related to Helm is going to get inside that particular directory. So I'm just going to go ahead and create a branch, right, and check out to that branch, right? And once we are inside this particular branch, let's just run Helm create, and this is going to create a dummy Helm application or Helm chart, and we are going to name it Helm. So this is the name of the directory, we can say, right? So if I just go ahead and try to hit enter, we can see that a directory has been created named Helm, and this has some dummy details. For example, deployment files, ingress files, and some other things, right? So let's just go ahead and first of all try to get rid of the YAML files that we don't want, right? Deployment.yaml, service.yaml, and service account.yaml. So now we are just left with very skeleton code, I would say. So we have already discussed about these files that we see here. So now what we are going to do is we are going to copy every manifest that we have in the manifests, right, inside the templates directory, because if you are creating Helm application for your application, if you are creating a Helm chart for your application, templates is a directory where everything is going to be, right? So every manifest should be copied inside templates directory. Like we saw, we had some files, for example, service account, service, and ingresses that we just have deleted, right? So yeah, these are all the files. These are all the files that should be there, right? Inside this templates directory. Okay, so let's just go ahead and try to do that. So copy from manifests, and but before that, if we have a look into the manifest files that we have, we can see that we have some duplicate files, right? For example, secret.yaml and service.yaml, ns.yaml, and things like that. So let's just go ahead and try to rename that. So this is going to be ns-mysql.yaml, right? And then this is going to be secret-mysql.yaml, and this is going to be service-mysql.yaml, right? Similarly, we are going to change it to ns-rest-api.yaml, and this secret is going to be secret-rest API. Similarly, this service is going to be renamed to rest api.yaml, right? So now that we have all the YAML files, all the resource manifests, let's just go ahead and try to copy them inside the templates directory that we just have created. So cp manifests mysql to Helm and templates, right? And we should be able to see things inside templates directory. So we are able to see deployment, ns mysql, pvc, secret mysql. So all the mysql files have been transferred inside templates directory. Similarly, we are going to copy over the things inside rest api to templates, right? And here we go. So we have a very simple Helm chart, we can say, right? And this Helm chart had some manifests inside this template directory, right? And this is how, or this is the structure of a Helm chart, of a Helm application. Now if I just go ahead and try to install this, so this is the directory where our Helm application is present locally, right? So what we are going to do is Helm install. Another thing that I would like to emphasize is I'm using Helm version 3 as of now. So yeah, I mean, there are chances, if you are using Helm 2, there are chances that the command formats are going to be slightly different, right? So Helm install, and then name of the application, or we also call it release name, right? So release name is going to be, let's say, lib, and we are going to install it in the namespace library, let's say. And now we are going to specify the Helm chart, right? And Helm chart is inside Helm directory, and this is almost it, right? That we want to do to install a Helm chart that is present locally, right? And if I press enter right now, as we have discussed in previous video as well, all the manifests that we have inside templates, all these manifests are going to be what should I say, they are going to go through a rendering engine, we can say, right? And then they would actually be applied into your target Kubernetes cluster, right? So every resource manifest that is there inside templates directory. But before doing that, what I want to show you is, if I just press enter, if I just type enter here, right, we can actually see the rendered version of the manifests, right? And this would make much more sense in a bit. But there are chances that, for example, for this pvc, we are using something from values.yaml, right? And after rendering, how this PVC is going to look like can be figured out by applying this try run flag while installing the chart, right? So let's just go ahead and try to hit enter, and I should be able to see every resource manifest that would be applied in the Kubernetes cluster, right? And this is how these are all the manifests that are going to be applied, right? So for example, pod, namespace, and every other thing, right? Now that we have a very simple, not very ideal Helm chart, let's just try to go ahead and let's just try to install it, and then we will actually look into the problem that we are going to face, then we are going to resolve it, right? So what I'm going to do is I'm going to remove the dry run, and then I'm going to hit enter, right? Another thing that I would like to specify is we are actually trying to install two applications, right? We have two applications. One is mysql and another one is REST API, right? People don't usually do this. They try to create two separate Helm charts for two applications, right? But just to give you an understanding of the things, I'm doing things this way. But yeah, people usually create two charts or n number of charts for n different applications. And it says namespaces library not found, so library, right? And if I just go ahead and try to install it once again, we should be able to see the output that is there in the notes.txt. And again, we have discussed it about it in the previous videos as well. So notes.txt is the file that is going to be shown once the chart is successfully installed, right? And once the chart is installed, to see all the charts that are installed, we can see Helm list. And if you know the namespace, you can specify the namespace using -n, right? Or you can just specify -- all namespaces, right? And we can see that lib is a release name that is installed in library namespace, right? Now to look into the resources that this particular chart has been created, since in this particular case we know that it is going to create two namespaces, database and REST API, and we can see that these two namespaces have been created successfully. And we can also go ahead and try to check the namespaces here. So this is for REST API, and there should be another namespace file for database namespace, right? So we can see that these two namespaces have been created, or in other words, we can also say that all the resource manifests that were there in the manifests directory have been applied. Obviously, after going through the rendering engine, let's say, they have been applied to your Kubernetes cluster. Now let's just go ahead and try to look into everything from database, because first of all, let's just make sure that database is running up and fine. And we can see that this particular pod is in pending state, and I know the reason. Maybe I'll make another video about how to debug these things in your cluster. But if I just go ahead and try to look into the PVC for this particular cluster, we can see that this particular PVC is in pending state, right? And the reason is standard storage class is not found. So if we just go ahead and try to look into this PVC, we can see that we have hard coded the storage class, right? So again, this is a very simple example, or one example of how Helm can help us to enable the users provide the values in the runtime or while installing the application. So what I'm going to do is I'm going to get this value from values.yaml, so that if someone is trying to install my application, they can provide or they can specify the storage class name while installing the applications. So let me just go ahead and try to open the values.yaml file, right? Let's not worry about the other things that are mentioned here. So what I'm going to do is I'm going to specify, again, this is a YAML formatted file. So what I'm going to do is database dot And for database volume, we want to specify storage class name, right? And by default, let's make it standard, right? And now if I read this storage class value from values.yaml, user would be able to specify a dynamic value for this particular field while installing this chart, right? So let me just go ahead and try to read this value. And again, to read these values, Helm provides some predefined objects, for example, .values, .chart, .release, and obviously some other named templates that we are going to look into. So what we can do is we can just go ahead and try to read that value. So .values and then database, right? And volume .storage class. Here we go. Storage class name. Yeah. So now if I try to install the application once again, right? And we specify the value for this particular field, database.volume.storage class name, to let's say something else, that particular storage class would be applied to this particular field in this particular PVC, right? So let me just go ahead and try to delete the application that we have just installed, right? While it's getting deleted, what I will be doing is, we can also, before actually installing the application, we are actually going to look into the manifests, rendered manifests, using dry run flag, right? Just to make sure that storage class has been replaced with the storage class that we are providing. So kdelete ns library, and if I just go ahead and try to run the same command, helm install, right? And now I'm going to specify --set, and using --set, what I'm going to say is database dot volume dot storage class name, and set this storage class name to the storage class name that is present in the cluster, right? So we have this particular storage class, right? And we actually want to look into the manifests, rendered manifests, right? So, and let's redirect this output into a file, let's say temp.yaml, so that navigating through that manifest file would be easier, right? And if I open temp.yaml now, and if we search for this particular PVC, right? So mysql pv claim, and here we go, we can see that rendered manifest now has storage class name set to do block storage, right? So this is a very simple example, I would say, of specifying the things, but this is how helps us, right, to achieve the things, to specify the things at the runtime, right? Now if I just go ahead and try to install the things, so helm install, and this time I actually want to install the things. If I press enter now, we should be able to see again. Let me discuss about this in a bit. We should not actually create this particular namespace manually. Usually what people do is, again, because one particular application is packaged in one chart, that application is usually deployed on the namespace where the chart is being deployed, right? So for example, since we are deploying it in the library namespace, the application that we are deploying through this particular Helm chart should be deployed in library namespace. But since we have two different applications, we are explicitly creating those two namespaces separately and then deploying those applications into respective namespaces. So Now, if I just go ahead and try to install this, we should be able to see after this everything running fine in both the namespaces. So we can see that things have been deployed. Don't worry about this as of now because we have not changed the notes.txt file. If I get everything from, let's say, database namespace, we can see that now at least MySQL pod is being created, right? So, and if we look into the PVC from database namespace, this is now bound, right? Now let me explain how this actually helps us. So when we created manifests for our application, we hard coded the PVC to standard, right? And even if we, let's say, we are trying to install it on DigitalOcean cluster, we know that the storage class that is available here is do block storage. If we hard code that particular value at this particular line, what if someone tries to install it on a cluster where we don't actually have do block storage class available, right? So for example, let's say they are trying to install it on either EKS or AWS or GKE or any other cluster self-managed cluster, right? So using values.yaml helped us in a way that they can specify the storage class dynamically, right, while installing this application. So for example, if I am on a Kubernetes cluster that has a storage class named, let's say, GP2, right? So what I would say is helm install this particular application hyphen set storage class equals to GP2, right? And in that case, value of this particular field is going to be changed to GP2, right? So this is how Helm helps us to distribute our application, right? So again, this is very simple example. Like we read values here, we can and here we go, the pod is up and running successfully. So the other thing that I wanted to discuss about is, like we read values here, we can read other things as well. For example, dot chart dot, excuse me, dot release and dot values as well, right? So the other thing that I would like to show is we can actually, there are a lot of other things that helps us with. For example, let's say if you have to change this particular value, right, to uppercase, there are let's say this value of this particular field should be in upper cases, right? So what you can do is you can use some predefined template functions that help provides us with, right? And then you can use those functions to actually apply into another function's output. So for example, we call this as pipeline. So for example, let's say if we have to quote it, right, quote the value of storage class name, what we can do is we can just specify quote here, right? And this is pipe operator, I would say, that is going to apply this particular operation in this particular output, right? So these are some other things, very, what should I say, helpful and important thing that help provides us with. Now let's take another example, right? So we also create secrets, right? So the MySQL instance that is installed here, so this MySQL instance right now has the password that we have specified over here, right? And this password is base 64 encoded. So if we try to decode that, this is the password, right? And using this password, we can actually log into the MySQL instance that we are running. So MySQL, and the password is going to be this. Yeah, and you can see that we are able to log into the MySQL instance. Now the problem is, what if the user wants to specify their own password, right? Because in this particular approach, we are almost saying that you cannot change the password, you will have to use this particular password, right? So there is another thing that we can change about this particular chart. So let's just go ahead and try to take the value for database root password, right? So we are going to say database dot root password, and let's say default value is Vivek, right? And let's read that value over here. And one thing that I would like to highlight is you can see that this particular value is base 64 encoded of your password, right? So if I mention dot values dot database dot root password, this is going to fail, right? And we are going to look into this why. So let's just go ahead and try to apply this once again. So first delete the Helm release that we have installed, and then we are going to reinstall it. So we are going to specify storage class do block storage and -- set database dot root password equals to, let's say, something else, right? And dry run so that we can actually see what is being rendered. If I hit enter here, this shouldn't work. So database dot root password. Okay, so let's just go ahead and try to look into the secret that has been generated, and I'm also going to explain why I was saying this should not work. So name of this secret is mysql password. Okay, so value has been set to something else, right? Now if I just go ahead and try to install it, this is not going to work because let's just look into the error. And here we go, right? It is just saying that illegal base 64 data, right, for this particular secret, right? And we know the root cause, right? Because this is expected as base 64 base 64 string, right? So now what we are going to do is, since getting base 64 password from user is not going to be a good idea, we are going to convert that provided password into base 64 using Helm functions, right? So if we look into the Helm template functions, and if we look into encoding functions, I'm going to specify or provide this link in the description if you want to. So base 64 encoding and base 64 decoding are the functions. So if I just go ahead and specify base 64 encode, right, and then we also want to, and this is pretty much it, I think. So we used pipeline here, and we used base 64 encoding function to actually encode the value that has been provided by the user. Now if I just go ahead and try to install the things now, I think things should work as expected, right? So let's just delete these two databases that our Helm chart creates, and then we are going to install our Helm chart again. Okay, I think we installed that in default namespace. So alright, now if we try to install this should be installed in default namespace, right? And the MySQL instance that is going to be get deployed should have this particular root password, right? So get pods from database namespace, right? And let's just wait for this particular pod to be up and running. Meanwhile, what I would like to discuss is all the values that we are specifying here, right, using hyphen hyphen set flag. These values can also be specified by creating a values.yaml file, or by creating a file locally. So for example, let's say you want to specify some custom values for these particular fields. You can create a file locally, right? And then you can specify these fields in the similar format, right? And then you can specify that file using hyphen f flag to helm install command, right? And here we go, it is running. If I exit into this particular pod, and we should be able to log into MySQL by providing the password that we have here, right? And here we go, right? So we are into MySQL. I'm exiting it, and we are. So this is what I wanted to discuss about, right? So now since we have two secrets being created, we can read the same thing into another secret as well. So for example, this should go into this particular file as well, right? And yeah, so this is how you can use values.yaml to read the values, and all those values can be specified while installing your application, right? And if I want to show you how you can specify custom values, right, using file locally, not and not using hyphen hyphen set flag, you can pretty easily do that. So let me first delete this from default namespace, and we are going to delete the name, the okay, it has been installed. Now let's just create another file. So let's say custom values.yaml, right? And in custom values.yaml, we are going to specify just the things that we want to change, and this is going to be do hyphen block hyphen storage, and root password is going to be secret password. And to install, what we can say is helm install, and we don't have to specify hyphen hyphen set. We can give the what should I say, custom values file that we have, right? And this should install the applications with the values that we have provided locally in the custom values.yaml. So I think we should have custom values.yaml somewhere here, right? And here we go, right? So now the MySQL instance that has been deployed has secret password, right? So this is another way of specifying the values while installing your Helm application. So another thing that I would like to discuss about is how you can read the values from using dot chart or dot release, right? So what people usually do is the objects that are being created, they depend on the release name that user is creating, right? So for example, let's say we are installing two applications, mysql and rest api, and for rest api the deployment name should be equal to the release name that user has provided. So if we take a look into the deployment name, as of now the deployment name is rest api, right? But we want this deployment name to be what the user has provided the release name to be, right? So for example, if we install using helm install lib1, right, the deployment name should be lib1 instead of rest api. So let's just go ahead and try to look into how we can achieve that. So templates, and this is the file that is responsible of creating that deployment, right? So again, there are a lot of things that we can make dynamic here. For example, images, and every environment variable, for example, we can read it from values.yaml and every other thing, right? But what I'm going to do is I'm just going to change the name here, right? And we can obviously read the name from values.yaml here, but I'm going to explain another thing and the aspect that is named templates, right, in case of helms, right? So if we have a look into helpers.tpl, right, so we have discussed that every manifest file, right, inside templates is treated as a Kubernetes resource manifest, right? Instead of some files, for example, notes.txt and other files that are starting from underscore or that are starting with underscore. So right, these are some specific files that are not treated as Kubernetes resource manifests, but every other file inside templates is treated as Kubernetes resource manifest, right? So if we look into this particular file, again, let's not look into the other thing that are already mentioned here. So let's say we want to get a namespace from the release name, right? So we can create a named template, or very simply, very naively, we can say that a function, right, template function. And this is how we create a template function. So using define, right, and then let's name it to be, let's say, deployment name, right? And then we are going to end this, right? So hyphen end, here we go. So now we can say that this is a function, and this function can be used from any of the manifests that we have here, right? So from rest api.yaml, what we can do is we can just call that function using include, right? And we are going to say dep.name, right? And we are going to also pass it the scope, right? We are going to discuss about the scope let's say right now. So some things about this particular function that we have. So these names are global, right? So there are chances that you have subchart, and in your subchart there are chances that you have function names or named templates with the same name, right? So there might be conflict. To resolve that, what people do is they name their named templates by this format. So chart and then actual name, whatever they want to. So since our chart name is helm, this should be actually library, not helm. So lib.name, right? And then in REST API we can call that lib.name, right? And if I just go ahead and if I want to just return a string from here, we can just return, let's say, changed name, right? And if I go ahead and try to see the rendered manifests, we should be able to see that the name for this particular deployment is changed name instead of whatever we had earlier, right? So if I try to install the things once again, but dry run, and in custom values, okay, we don't want to specify anything in custom values, and redirect it into temps.yaml. So now we should be able to see that the name for this particular deployment is going to be changed name, and we are going to modify it a bit. Again, this print is a Helm template function, predefined function like base 64 encoding that we have seen earlier. So if we search for print here, we should be able to see all these. These are all these string functions that Helm provides us with. This is pretty useful documentation if you ask me. Okay, so Helm list, and let's delete the chart first. So what we are going to eventually do is we want to have a logic here. If deployment name is not specified from values, right, the deployment name should be the release name, right? And if a value has been provided from values.yaml, or while installing the application, that should be the deployment name, otherwise the name of the release. So that is the logic that we are going to implement here. Yeah, and temps.yaml, if we look for this particular deployment, right, name of this deployment should be changed name, and you can see that the name of this deployment is changed name here, right? Now let's say we want this to be more dynamic, and we want to specify, or we want to make sure that if a name is specified, or if a name is provided for, let's say, application dot name, and by default this is REST API, right? And if application dot name is provided, then deployment name should be changed to that. Otherwise deployment name should be release name, right? And release name again is this name that we are specifying here, right? So to implement that, we can have control flows as well. So for example, we discussed about functions, right? Similarly, we can have control loops, control flow as well. So if statements, and we can range over the things as well. So if we can take an example here, so if values dot full override name, so if values dot application dot name, right, if it is provided, in that case print this, right? Else the name should be release name, right? So release dot name, is this correct? Let me, yeah, so release dot name should be used, right? So does this make sense? So what we are saying is, in REST API.yaml, we are saying that this template function is going to be used to specify or to provide name for this particular deployment, and this rendering happens when we try to install it, and all these manifests go through rendering engine or templating engine that we talked about. So here if application.name is not provided, right? If application.name is not provided, in that case, the name of the deployment should be release name, right? Otherwise, the name of the deployment should be whatever the value has been provided, right? Let's just go ahead and try to apply this and see the result. And we are not specifying the values.application name. So name of the deployment should be release name, right? And lib-release-name, and the temps.yaml that would be generated. Okay, something seems to be wrong. Okay, so the problem here is for if else we have end. So this end is for this particular if statement, but we forgot to add end for the define, right? So for example, for every function in programming languages, we do have an ending curly brace, let's say, right? So this is, let's say, ending curly brace for this particular function. Okay, and if we look into temps.yaml, and if we look into the name, here we go. The name is lib release name because we have not specified name in the values.yaml, right? So that's why the name is being taken from release name, right? Similarly, if we specify the name from values.yaml, right? So name from values, right? And if we try to do the exact same thing now, we should be able to see the name being generated as from values. Okay. Application.name. Let's see. Okay, so resolving this might take some time. Let's refer to some examples here. If it's not going to work, it's okay. I think you get the idea. And here we go, name from values, right? So now the name of the deployment is going to be name from values. If we don't dry run that, if we just go ahead and try to install that, and we look into the deployment in the REST API namespace, the name of that deployment should be name from values, right? So yeah, this is what I wanted to discuss about. And you can use named templates to make your Helm chart very dynamic and very powerful, I would say, right? Another thing that I would like to discuss is this is the scope that is passed, right? So for this particular template, the scope that this particular template has is what has been passed when this particular template was called, right? So for example, since we passed, and from this particular, while passing the scope, we can pass any scope that we want to. For example, we can also pass, let's say, dot values or dot chart from here, right? Or dot release as well. But in that case, we would be able to just access the things inside dot chart, right? So we would not be able to access dot values, right? So that is about scoping of these functions, right? Now what I'm going to do is I'm going to push everything again into my GitHub repo for this particular for this part in this particular branch, that is Helm chart. If you want to modify some things, you can do that. Eventually I would merge it into the master, right? So yeah, this was pretty much it that I wanted to discuss about. Again, I'm looking into the notes that I have, if there is something else that I wanted to discuss about. Yeah, so either we can use to call the template functions, we we have a named template here, right? lib.name. And to actually use it or call it, we used include here. But there is another what should I say, another directive that we can use, that is template, to actually call that. So instead of include, we can use template as well, but there is difference between include and template. So include is a function, but template is not. So if you use include, you can further use another functions, right, after pipeline. So after using pipe, you can use another helm predefined functions, but in the case of template, you won't be able to. So yeah, this was pretty much it that I wanted to cover. Again, this is there are a lot of other things that Helm provides us with, but since this video would be much longer if I try to cover everything, this is a starting block, I would say. Once you have understood these things, maybe you can try to understand things on your own. And this is very helpful file, I would say. So you can see that you can actually refer this particular file to see how how these functions are being used in actual manifests, in by generating a simple Helm chart, right? So yeah, this was pretty much it. If you think this is helpful for you, maybe you can consider liking and subscribing, share it with your friends. And yeah, thank you so much.